1923 to 2007. Earthquakes by quarter are shown in gray, and you can see natural background. We get 1,000, 2,000, 3,000 earthquakes a year, beginning back in '73. In 1985, we had a big earthquake swarm. Things died down, and in 1995, things picked back up, and they died down again. Correspondingly, here's a diagram showing how fast the caldera is going up and down. So between 1923 is when they first installed the monuments we measured, to 1975, it was going up at about 2 centimeters per year, so that's roughly an inch per year. That continued on over to the time of this earthquake, 1985. Then the caldera started going down, went back up here in 95, went back down. So the caldera breathes, in a sense, and suddenly in 2004, it reversed motion and started going up at 7 centimeters per year maximum. And we know that because we have GPS stations shown here, the locations of the red arrows. And the red arrows are showing the uplift of the Yellowstone caldera. And going back as far as 1997, we have data. This is the vertical component of motion for these 6 GPS stations. I won't go into them, except to point out the caldera was going down here, as you can see, for basically 7 years, and then suddenly it reversed and went up. And these show, each set of green points are actual measurements taken once a day, showing the uplift of the whole caldera. And this is...
Is that significant? I mean, is that something...
Well, it is, yes, very significant. It's the highest rates we've ever observed historically in Yellowstone. Of course, we weren't here prehistorically. And so these are very high rates. We don't know exactly what it means, but here's a picture where we superimposed a satellite radar image shown by the rainbow color patterns, which are individual patterns of changes in elevation of about 3 centimeters per year. Here are the uplift arrows from the GPS measurements, and the black show that it's expanding laterally. And you can see this body extends from the southwest side of Yellowstone up to the northeast side. It's an area that's about 50 miles long, and it's about 30 miles wide. And it's related, we think, to fluids that are pressurizing in this crustal magma body. And this red box or feature right here is called the seal. That means a horizontal layer of magma that is just expanding as fluids are coming in, probably from the bottom of the magma body, just opening it up. And if it opens up, it lifts the Earth's surface. And over here at North Geyser Basin, there's a sill that's going down, drops the Earth's surface right here. So this is the body lifting up. This is the body that's going down. So we think magma is intruding from in here and filling this up. And it's just part of natural cycles of these giant calderas. They do go up and down. We've seen similar cycles in the Long Valley caldera in California, calderas throughout Italy, different calderas in the Southwest Pacific. On occasion, you know, when they erupt, and these are active volcanic systems. No reason to think either earthquakes or volcanism will stop. What form it will take, we don't know. It could be very, very small, just gas, steam, water eruptions, up to eruptions the size of a Mount St. Helens eruption, which we had in the Cascade in 1980. Or, I mean, and of course, there's an exceedingly small chance of another giant eruption. That's been hyped up so much because of the people thinking that it was, of course, imminent. Sure, we've had a lot of super eruptions along the track of the hotspot, but we don't think we're in any kind of threat for a super eruption. On the other hand, that's why we operate the Yellowstone Volcano Observatory, which has a branch of it here at the University of Utah. It records earthquakes, records volcanic motions from GPS, so we can see any precursory earthquakes or precursory deformation that would tell us. And an impending volcanic event, I think we would see. for weeks, perhaps even months before it would happen. I mean, the fact that Yellowstone is about 1,000 feet higher than the surrounding region,